Whoa! Would you look at that? We have a line here. But that's not so useful for a mathematician. A mathematician can do so much more with the equation of that line. It's much more powerful. So how do we find the equation of this line here? Well, we have a strategy over here, and we're going to do these 3 steps. Step number 1, we want to find the gradient or the slope, which is called m, confusingly. To find the gradient, we can use, we need 2 points to find the gradient. So for example, this point here and this point here, 2 points, any 2 points in the line will work just fine. This point here, the x-coordinate is 0 and the y-coordinate is -2. So that's this point. And the other point, it tells us the coordinates, so we have that point there. Well, now we can figure out m using the gradient formula. And it looks at we can replace it actually. We've got equals, let's put our fraction bar in. y2 is the y-coordinate of the second point. y1 is the y-coordinate of the first point. So I've got y2 minus y1 is -2. You might see how I've got 2 negative signs here. One of them came from above, I copied that one down, but then I went to replace y1 with its answer, and y1, its value is -2. So that's why I got 2 negative signs here, because y1 was negative. On the bottom, on the denominator, x2 is the x-coordinate of the second point, which is 3, and x1 is the x-coordinate of the first point. So 3, take 0. You might find a handy little trick to help you is the first coordinate is always x, and the second coordinate is always y. So that can help. And then this here, this is the first point. In fact, it's that point there. So we can put x1, y1, and x2, and y2. Cool. X coordinate of the second point, right? Now we can simplify this fraction. On the numerator, I've got 2 minus -2. 2 negatives next to each other make a positive. And 2 plus 2 is 4. So the top is 4, the bottom, 3 take 0, is 3. So that's the gradient, and I can't simplify that fraction anymore. Let's do step 2 now. Let's find the y-intercept. The y-intercept, it actually has on the diagram here, on the graph, the y-intercept is where it crosses the y-axis, and you can see it crosses right here. The y-intercept is -2. We call the y-intercept c. As a tradition in mathematics, the y-intercept is always c. So now we know what our m is, the gradient, and we know what our c is, the y-intercept. We should be able to write the equation of the line. We're going to substitute into y equals mx plus c. When I say substitute, I mean replacing m with 4/3 and replace c with -2. So let's do that. First, write the general equation of a line, y equals mx plus c, and then replace things. I'm going to copy down the y, copy down the equals. M I can replace with 4/3. The x I can copy down. The plus I'll copy down. And the c I'll replace with -2. Cool. It's nice to simplify your answer if you can. And there's only one thing here that you could simplify, which is a positive and a negative together make a negative. So you can jump straight from this line to this one if you want, but that's why I just ended up with a negative there, because positive and a negative makes a negative. Okay. So this question is done now. We've found the equation of that line. Let's do this one now. This question here is the same kind of question. It doesn't have a graph of the line though, which I guess makes it harder. For that reason, I'll solve it a different way, but the same technique will work. It says to find the equation of a line with y-intercept -3. When you see y-intercept of -3, it's handy to write above that what that means. Remember that the y-intercept is c, it's called c. So if you see what the y-intercept is, then write c equals what that is. That's a little equation that can help you. So that's one clue to the puzzle. We've already done step 2. It's already told us in the question what the y-intercept is. We want to find the equation of a line which passes through this point. I'm going to do this one a little bit of a different way. I'm going to put this piece of information, c equals -3, into this formula. I'm going to substitute. And if I replace c with -3, then I get this formula. Why? Well, because now this equation only has one unknown constant here, the m that we need to find, whereas this one had 2. So now that this one is a bit simpler, y equals mx take 3, the only thing I have left to find is m, and I can use this point here to help me find it. How, you ask? Well, this point lies on this line. So if I replace x with 5 in this equation, and I replace y with -4 in this equation, then I will get a true equation which I can solve. And that will give me my answer for m. So let's substitute, let's replace. I'll replace or substitute -4 into y. M, we don't know, so m will just stay there. X, I'll replace with 5. Instead of writing m5, I'm going to put the multiply sign there. Because remember, between two letters, there's an invisible time sign. So this means m times 5. And then the -3, I can copy down. Can you see that I've replaced y and x with their values, or with at least one point that is on the line, so that now I have a true equation which only has one unknown letter in it, which I can solve to figure out that letter. I'll rewrite this in a way that we've seen before. Normally, instead of m times 5, we would write that as 5m. And now we can start moving terms around. I'm going to move my numbers to the left, although it doesn't really matter as long as you move them all to the same side. So I've got a term here, a term here, and a term here. So the -3 I'm going to move to the other side and it will become +3. The -4 copies down, the equals copied down, and the 5m gets copied down. Now I can replace -4 plus 3. Well, if I'm in debt $4 and then I get $3, well, now I'm only in debt $1. Picturing a number line is probably the best way to tackle those. And I can copy down the equals and copy down the 5m. Now, -1 equals 5m. I know what 5 times m is. What's the opposite of multiplying by 5? It's dividing by 5. So that will move to the other side and become -1 divided by 5. If you're not sure about this, then by all means, go back and revise solving linear equations, the early parts of solving linear equations. Okay, so we know what m is, the gradient, and we know what c is, the y-intercept. That is all the information we need. Now we can substitute into y equals mx plus c, but instead of m, I'm going to write -1 over 5. The x goes there, and c is -3. So this is the equation of the line. Just to prove to you that this equation really does match this question here, I'm going to graph it using Desmos. I'm going to go into desmos.com and write y equals -1/5, and then do the right arrow to get out of there, x, and I think it was -3. Let's go back. Yeah, -3. And we wanted it to have a y-intercept of -3. Let's check. Yeah, it crosses the y-axis at -3, so it does that. And we wanted it to go through the point 5, -4. I'll plot that on this Cartesian plane here, 5, -4. Yeah, and sure enough, this line is the only line that goes through this point and also has a y-coordinate, sorry, a y-intercept of negative 3. Neat!